In the vast expanse of space, there exists a class of galaxies so mysterious, so paradoxical, that they challenge everything we thought we knew about cosmic structures. Meet the ultra-diffuse galaxies, cosmic phantoms that contain as much mass as our Milky Way, but spread their stars so thinly that they remain nearly invisible to all but our most powerful telescopes. For centuries, these ghostly giants lurked undetected in the darkness of space, their light so faint that even nearby examples escaped the notice of astronomers. Imagine taking all the stars in our Milky Way and spreading them across a volume many times larger. The resulting structure would be so diffuse that from Earth, it would appear almost transparent against the night sky. It wasn't until the development of advanced telescopes and ultra-sensitive digital cameras that we finally caught a glimpse of these elusive structures. The first confirmed ultra-diffuse galaxies were found in the Coma cluster, where astronomers noticed strange, ghost-like smudges that defied conventional categorization. What initially appeared as imaging artifacts or lens flares turned out to be massive galaxies, each spanning tens of thousands of light-years, but containing only a tiny fraction of the stars we'd expect for their size. These galaxies break virtually every rule we thought we knew about galactic structure. They're enormous, but empty, massive, but barely visible, ancient, but seemingly underdeveloped. In a typical galaxy, we expect to see densely packed stars, especially toward the center. But ultra-diffuse galaxies spread their stellar populations so thin that you could fly through one and barely see any stars around you. Their discovery has opened up one of the most intriguing mysteries in modern astronomy. How can galaxies this massive remain so diffuse? And what are they telling us about the fundamental nature of our universe? When astronomers first realized what they were seeing in ultra-diffuse galaxies, it shattered nearly every established model of galaxy formation we had developed. Traditional galaxy formation follows a predictable path. Gas clouds collapse under gravity, stars form in dense regions, and the resulting galaxy develops a clear structure. But ultra-diffuse galaxies seem to ignore these rules entirely. These cosmic rebels pack the same mass as the Milky Way into a space nearly 100 times larger. It's like taking a bustling city and spreading its population across an entire continent. The sheer size of ultra-diffuse galaxies presents a fundamental problem. Their stars are so far apart that they shouldn't be able to hold together as a single structure. In normal galaxies, the gravitational pull between stars helps maintain the galaxy's structure. But in ultra-diffuse galaxies, the stars are so distant from each other that their mutual gravitational attraction is incredibly weak. The only way these galaxies can exist is through the presence of enormous dark matter halos, acting like an invisible scaffold that holds these sparse stellar populations together. These dark matter halos are truly massive, often containing thousands of times more mass than all the visible stars combined. They create a gravitational cradle that prevents the galaxy from flying apart. Perhaps the most perplexing aspect of ultra-diffuse galaxies is their bizarrely low rate of star formation, despite having plenty of raw materials to create new stars. While normal galaxies continuously form new stars from their gas reserves, ultra-diffuse galaxies remain eerily quiet. It's as if their star-forming machinery has been switched off, leaving them frozen in a state of cosmic suspended animation. The gas in these galaxies is so spread out that it rarely reaches the density needed to collapse and form new stars. They're like cosmic ghost towns, with all the building materials for a thriving galaxy, but almost no construction taking place. These peculiar properties raise a profound question. Are ultra-diffuse galaxies failed attempts at normal galaxy formation, or are they showing us an entirely new path of galactic evolution that we never knew existed? As we venture deeper into the enigma of ultra-diffuse galaxies, we encounter perhaps their most striking feature: their extraordinary dark matter content. Meet Dragonfly 44, an ultra-diffuse galaxy that shocked the astronomical community. This ghostly giant contains so little visible matter that 99.99% of its mass exists as dark matter. While a typical galaxy like our Milky Way contains about 85% dark matter, Dragonfly 44 takes this to an extreme. It's as if we've found a galaxy made almost entirely of this invisible substance. Given their enormous mass, these galaxies should contain billions of stars. Instead, we find vast empty spaces where stars should be, suggesting that dark matter has somehow prevented normal star formation. The stars we can see in these galaxies are like rare islands in an ocean of darkness. Where we expect to find dense stellar populations, we instead find mostly empty space, held together by an invisible force. Ultra-diffuse galaxies have become natural laboratories for studying dark matter, offering unique conditions we could never recreate on Earth. By studying how light bends around these galaxies, we can map their dark matter distribution with unprecedented precision, revealing structures that challenge our theoretical models. These galaxies appear to be embedded in massive dark matter halos that extend far beyond their visible boundaries, connecting them to the cosmic web in ways we're only beginning to understand. The dark matter dominance in ultra-diffuse galaxies breaks our usual understanding of the relationship between dark and visible matter, suggesting these cosmic phantoms formed through unusual processes. In most galaxies, we see a consistent ratio between dark and visible matter. Ultra-diffuse galaxies completely shatter this pattern, containing up to 10,000 times more dark matter than expected. Before we continue exploring these fascinating structures, take a moment to hit subscribe and join us on our journey through the cosmos. These dark matter mysteries are just the beginning of what we're uncovering about our universe. The discovery of ultra-diffuse galaxies has sparked an intense debate in the astronomical community. Are these strange objects survivors of cosmic violence or pristine relics from the early universe? One compelling theory suggests these galaxies are the survivors of ancient collisions. Like shipwrecks preserved in the cosmic ocean, they may be the remnants of once normal galaxies that were violently transformed. During these cosmic collisions, the gravitational forces can strip away stars and gas, while the more massive dark matter halo remains intact. This could explain why ultra-diffuse galaxies have so few stars relative to their total mass. Recent observations have revealed telltale signs of past trauma in some ultra-diffuse galaxies, including distorted shapes and streams of stars that appear to have been torn away. These stellar streams, like cosmic scars, provide strong evidence that at least some ultra-diffuse galaxies were once normal galaxies that underwent catastrophic encounters. But not all ultra-diffuse galaxies show signs of violent pasts. Some appear remarkably pristine, leading to an alternative theory about their origins. These galaxies might be living fossils from the early universe, primitive structures that never completed the normal process of galaxy formation. Like seeds that never fully grew into trees, they remained in a stunted state. The pristine hypothesis suggests that something interrupted these galaxies' development billions of years ago, leaving them frozen in a primitive state. One possibility is that their gas was heated by nearby galaxies or cosmic events, preventing it from cooling and forming new stars. This would explain their incredibly low star formation rates and diffuse nature. The difference between normal galaxies and these cosmic phantoms might have been determined in their first few billion years, when critical processes either proceeded normally or were mysteriously interrupted. As we study more of these mysterious objects, we're finding that both theories might be correct. Ultra-diffuse galaxies could represent a diverse population with multiple origin stories. Each ultra-diffuse galaxy might tell its own unique story. Some bear the scars of violent pasts, while others appear to have remained unchanged since the early universe. The discovery of ultra-diffuse galaxies hasn't just added a new chapter to our cosmic story. It's forcing us to rewrite the entire book. Around the world, astronomers are turning their most powerful instruments toward these ghostly giants, gathering data that challenges our most fundamental theories about how galaxies form and evolve. Every new observation forces us to expand our models of galaxy evolution. What we once thought was a simple path from gas cloud to mature galaxy has become a complex web of possibilities. Ultra-diffuse galaxies might be the missing link we've been searching for. A window into processes that shaped the early universe but were previously invisible to us. The next generation of telescopes, including the Vera Rubin Observatory and others, will allow us to detect thousands more of these ethereal structures, potentially revealing entire populations we never knew existed. If ultra-diffuse galaxies are as common as early surveys suggest, we might be seeing just the tip of an invisible cosmic iceberg. New surveys estimate that ultra-diffuse galaxies might outnumber normal galaxies by a significant margin. We're beginning to realize that what we thought was empty space is actually filled with these ghostly structures. These galaxies might hold the key to understanding dark matter's true nature, showing us how this mysterious substance behaves when nearly isolated from normal matter. By studying how these galaxies cluster and move, we're mapping dark matter's influence with unprecedented clarity, revealing patterns that could help us understand what this invisible substance really is. As we peer deeper into the cosmos with new tools, we're preparing to unlock even more secrets about these mysterious structures and their role in cosmic evolution. The next decade will bring revolutionary new instruments designed specifically to study these faintest of galaxies, promising to reveal countless more cosmic phantoms lurking in the darkness. Ultra-diffuse galaxies remind us that the universe is far stranger and more diverse than we imagined. They challenge us to think bigger, look harder, and never stop questioning our assumptions about the cosmos. Thank you for joining us on this journey through one of astronomy's most fascinating mysteries. Don't forget to subscribe and join us next time as we continue to explore the hidden wonders of our universe.